Alright, 10.4, use inscribed angles and polygons. Alright, an inscribed angle. An inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. So for example, this is an inscribed angle. Unlike a central angle has its vertex in the center. An inscribed angle has its vertex on the actual circle. Okay? Now the intercepted arc would be this here. Now I'll write that out. The arc that lies in the interior of an inscribed angle and has endpoints on the circle is called the intercepted arc of the angle. So this, I'll use a different color. This would be the intercepted arc because it's intercepted by the angle. Okay? Alright. Inscribed polygon and circumscribed circle, I'm going to do those two together. A polygon is an inscribed polygon if all of its vertices lie on the circle. So this quadrilateral here would be an inscribed quadrilateral. It doesn't have to be a four-sided figure. It could have as many sides as you want. As long as all of its vertices are actually on the circle, it's an inscribed polygon. A circumscribed circle is a circle that contains the vertices of an inscribed polygon. So this circle, because it contains an inscribed polygon, would be a quote-unquote circumscribed circle. Okay? Alright. Theorem 10.7. Let me go back to blue. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So, in this case, the measure of angle ADB is 1/2 the measure of arc AB. Please don't get this confused with, central angles. Central angles, if the vertex is on the center, it equals the same measure as the arc. But if the angle is inscribed, it's half. Okay? So for example, find the indicated measure in circle P. The measure of angle S. Okay, so angle S is this angle here. The arc is 60. So the measure of angle S equals 1/2 60. Oh, I think they want us to put the actual arc first. So arc RT, which is 60 degrees. Half of 60 is 30. Alright, the measure of arc Q, or RQ, that's this arc here. In order to find this arc, what we need to do, we know that this is, what's going on here? There we go. This is a semicircle, which means this whole thing is 180 degrees. If we can find this arc, we can subtract it to find RQ. Alright, so QS. QS is going to be twice the measure of angle R. And the measure of angle R is 37 degrees. So 2 times 37, that's going to be, let's see, 74. And this, like we said, is going to be 180 minus 74 degrees. So this is 74 degrees. The whole thing is 180. 180. I guess they want us to write out the arc here. We can do that. Okay. Subtract 106 degrees. Alright, let's go on to page 2. Find the measure of arc HJ and the measure of angle HGJ. What do you notice about these two angles? Okay, so from theorem 10.7, you know that arc HJ, that's this arc here, is going to be twice the measure of this angle, HFJ. HFJ is 39 degrees. 2 times 39 degrees is 78. Also, the measure of angle HGJ, that's this angle, equals half this arc. Okay, so it's 1/2 78 degrees, which is 39 degrees. So these angles are congruent, which makes sense because they open up into the same arc. which leads us into theorem 10.8. If two inscribed angles of a circle intercept the same arc, kind of like what they did up here, then the angles are congruent. So in this case, ADB is congruent to angle ACB. Alright. So, name two pairs of congruent angles in the figure. Notice that angle QRP, it's this angle, and QSP intercept the same arc. Hopefully you guys can see that. This angle and this angle both intercept this arc. So, these two angles are congruent by theorem 10.8. Also, use a different color. Angle RQS and angle RPS intercept the same arc. So, they're congruent. Alright? Alright, you guys can do the checkpoint. Let's go on to page 3. Alright, theorem 10.9. If a right angle is inscribed in a circle, then the hypotenuse is a diameter of the circle. Okay, so anytime you have a right triangle, the hypotenuse will be a diameter automatically. Okay? Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle and the angle opposite the diameter is a right angle. So if you have a diameter, okay, and that diameter is one side of the triangle, it's automatically a right triangle. Okay? So the measure of angle ABC is 90 degrees if and only if AC is the diameter of the circle. So, for example, a security camera rotates 90 degrees and needs to be able to view the width of a wall. The camera is placed in a spot where the only thing viewed when rotating is the wall. You want to change the camera's position. Where else can it be placed if the wall is viewed in the same way? Okay, from theorem 10.9, you know that if a right triangle is inscribed in a circle, then the hypotenuse of the right triangle is a diameter of the circle. So draw the circle that has the width of the wall as a diameter. And they're actually nice enough to draw it for us. The wall fits perfectly with your camera's 90-degree rotation from any point on the semicircle in front of the wall. So you could place the camera at any one of these 3 points and you can still get the whole wall. Alright. Okay, theorem 10.10. A quadrilateral can be inscribed in the circle if and only if its opposite angles are supplementary. So, these points lie in the circle if and only if these angles add up to, this angle and this angle equals this angle plus this angle, which equals 180 degrees. Alright, last page. Find the value of each variable. Okay, so using the theorem we just learned, opposite angles have to be supplementary. So PQRS is inscribed in a circle, so opposite angles are, like I just said, supplementary. So in this case, angle P and angle R add up to 180 degrees. Angle P is 100 degrees, angle R equals Y. I can subtract 100 from both sides and Y equals 80. Likewise, over here, we need to do Q and S also. Q plus S also adds up to 180 degrees. 88 plus X equals 180. I'm going to subtract 88 from both sides, and I believe that's 98. I'm sorry, not 98, 92. Okay. Alright, same thing over here. These angles are also supplementary, the ones that are opposite. Angle J and L add up to 180 degrees. 8x plus 4x equals 180. So 12x equals 180. If I divide both sides by 12, let's do that over here. You should get 15. Okay, angle K and angle M also add up to 180. 3y plus 3y equals 180. I'm going to divide both sides by 6. Y equals 30. Alright, and you guys can do the checkpoint. That's all.